3 times more likely to be approached by bats than calling males, all else being equal. So this sort of corroborated what we were seeing in the diet of these bats. I think, can someone tell me if I'm out of time? I'm almost at the end.
You have just about 5-ish minutes left.
5 minutes, yeah, perfect.
Thanks.
So given that, we have these calling males who might be approached, and we have females for whom flight is so dangerous. In one of these canopy katydids, we actually asked, well, what do females do if flying is so risky? So we tried these very, canonical phonotaxis experiments with this canopy katydid species, where we had a speaker which played out the call of the male of her species. And what any self-respecting cricket will do is walk down to this T and approach the speaker, maybe fly to it. I'm going to show you. So the female is at this end of the T, the speaker is over there in the next video, and I'm going to show you what she does. So you can see the female standing on a leaf, and you will hear the playback of the male now. Watch the leaf carefully. Now you can see it's beginning to shake that leaf, right? She's not walking. Every time the male chirps, she tremulates. And you can now record that. So the same thing I showed you in the video, here's the acoustic signal with the microphone. Here's the female's tremulatory signal that we can record on the branch using a laser vibrometer. And what you can see is that for every chirp of the male, in a very sort of timed way, the female is putting out a tremulatory or vibrational response. What this vector diagram shows you below is how tightly these two are coupled. And you can see that most of these are very long vectors. So basically, there's a very tight timing between when the male makes his call and the female produces this vibration. So we actually discovered this acoustic vibratory duet, and at that time, that was the first of its kind. And we then asked, is this really a signal? Do females pay attention to it? Males pay attention to it? And to do that, we did a series of experiments with males where we actually simulated the female's vibratory signal with an electromagnetic actuator and asked whether males would prefer branches with the vibration to branches without. And the answer to that, I won't go over all these controls, is yes. When you have these vibratory signals, then males actually follow those vibratory signals. We have since confirmed them in live duets. So what we seem to have here, the story that we have so far is, yes, there are males who are calling out for females, and yes, bats do prey upon them, but bats seem to prey more on female katydids than on males. For some reason, flight appears to be a much riskier behavior than calling. And in the context of this, we discovered this novel communication system, a multimodal duet. And we hypothesized possibly that this sort of tremulatory duet may have evolved because female katydids would prefer to use a low-risk strategy and communicate with males who are calling by producing this non-risky vibrational signal rather than risk their lives by flying. This is something that we have been testing out. So let me quickly sum up. When we look at signaling and searching, the assumed norm has been that the predation risk is higher for males. They're the more conspicuous ones. They are at greater risk. What have we found so far? With bats and katydids, the canonical system, the predation seems female biased, or some more recent experiments have shown us it could be equal, but it's certainly not male biased. And in the tree cricket system with a spider predator, we have seen the same thing, equal and low risk for both sexes. So I'd like to end by saying, this may just be the tip of the iceberg. And we need a lot more comparative work across systems, signals, modalities, ecological context to actually fully understand the diversity, the costs and benefits of signaling. I'd like to acknowledge fantastic set of students and postdocs over the last 25 years now, who have done all of this great work. I have referred to some of them as I went along. Ritik Deb and Monisha, who did a lot of the work with the tree crickets and female preferences and the ecological context. Natasha Matre, who was my first PhD student, but who also helped out with the work on baffling that we did with the tree crickets. My postdoc Raghuram, who did the grueling work of misnetting in the forests to identify the bat community as well as the behavioral experiments with the bats. My other postdoc, Kaveri Rajaraman, who discovered the multimodal duetting. Viraj Dosekar, who did all of the work on predation risk of tree crickets. Kasturi Saha, who's following up with the bat katydid predation risk story. Our two fantastic field assistants, Manjunath and Sudhakar, without whom nothing would be possible, be it walking through the forests at night, be it making the enclosures for cages, catching animals, etc. And a fantastic sets of undergrad interns over the years who have helped us out with our experiments. I'll stop now. Let's take questions.
Great. Thank you so much.